first one, right? We are not asked to find the second, right? You may be muted.
Right. Yes.
Okay, very good. So first of all, here I have to use the product rule because this is function 1 and this is function 2. Here there is no problem. So every time I use the product rule, I have to have two quantities, two terms. When the first function is prime, I get 1. So this is hyperbolic sine plus x. When I differentiate hyperbolic sine, I get hyperbolic cosine minus. There is no sign change for hyperbolic cosine. So when I differentiate hyperbolic cosine, I get hyperbolic sine with minus in front. But now I realize that these two are like terms. So negative 9 plus 1 will be negative 8, hyperbolic sine. And then this I have nothing to do to it. I just have to copy it. So this is it. So I'm not sure, did they make an error? Was it something? So they said x cosine, hyperbolic cosine minus 8. Okay. And you had the same thing. So something went wrong.
Not sure. Wait, can you go second?
So yeah, you just I think you had you
Is
typed
that not
you
like
typed
9
you
times,
typed
but
you
not
typed in
times?
here cosine instead of sine.
So you don't use product rule for like the 9 cosine hx?
But don't we have the rule that says a constant times the function prime is the constant times the function? But even if you use the product rule on 9 times x, then you have 9 prime is 0, 0 times x plus 9 times x prime, which is 1. So you still get 9. But we never use the product rule if it's a constant times a function, right?
Okay, well, that's what I did.
Okay, so we never need to use that. And if you do, it's still the same thing because this is 0.
So there's no need to use. So if it's just number.
Yeah, this is the formula. If we have a constant times a function, we leave the constant alone. Next question, anyone? Okay, if we don't have other questions, and thank you so much. You're making my life so much easier. And I'm very pleased and very proud of you. The homework does not take me long to grade. It's check, 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 35 out of 35. Check, check, check. Thank you. That's my dream. I don't want to spend time on grading. I just want to do this. Check, 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 100%. It takes me 3 seconds to grade. Otherwise, if I need to give partial credit, then I ask myself, okay, should I give 7 out of 10? Should I give 8 out of 10? And it takes me forever. But if you do this for me, I will reward you. I love it. Okay, thank you. Enough of that. So we move on to section 3.5, implicit differentiation. Okay, so if I'm given a function, let's say f of x equals x squared, I have the function, I differentiate, and I get 2x. And this is direct. What do I mean by direct? I'm given the function. I have the function, so I'm finding the derivative directly. Well, what do I do if I have a situation like this? So specifically, I'm asked to find dy over dx. You can say, why don't you use f prime? When it comes to implicit differentiation, it's okay to use f prime. It's okay to use y prime. but I suggest don't. Use this notation. They all mean the same thing. This and this and this are all the same. What is the downfall of using this notation? You may not see the prime. Who knows? So this is more dangerous. This is the best notation for implicit differentiation. I still haven't explained what implicit differentiation is yet. Okay, so bear with me for a second. So in addition to the fact that this is by far the best notation for finding the derivative of y, so that's in addition to that. The second very important note that I want to make here is this tells me that f, or the function, is y, which is a function of x, which means x is the independent variable. One more time. So we are going to use this notation, not this and not this, for two reasons. One, not to get confused and forget something, yada yada. And the second is because it tells me clearly that y is a function of x. Okay, so I'm going to ask, can anyone solve this equation for y? Y is our function. The answer is no. I cannot solve for y. If I could, if it didn't take a long time, I would solve and then differentiate directly. But I can't. No one can by hand do this. Solve for y. Look, y is right here as the power, and also y is right here in a product. So can we still get an expression for y prime? Although we're not going to use this, we're going to use dy over dx. The answer is yes. However, it will depend on y, which is okay. So we will differentiate both sides. This is very similar to for example, solving an equation like this. Natural log x equals 4. I use the inverse function, right? E to 4 equals x, right? So I'm applying a procedure to both sides. Maybe better example is something like this. I'm applying a procedure to both sides at the same time to solve for x. I get x plus 1 on the left-hand side, 16 on the other, so x equals 15. Same thing here. So I have an equation, and I'm allowed to apply a procedure, the same procedure, of course, to both sides. And I choose to apply this procedure because I'm asked to find dy over dx. So I will differentiate the left-hand side and the right-hand side and then try to solve for this. Okay, so I will start with e to the y. On the side, I'm going to refresh your memory on the formulas. E to a function prime is e to the function times the function prime. So remember, y is a function. This tells me so. So it's e to y times the derivative of the function, dy over dx. E to a function is e to the function times the function prime. I will not write this. I have to write this. Here I have a product. This is function 1, and this is function 2. Plus, whenever I apply the product rule, I have to get two terms. The first function prime is 1, so then I get 2y. Then I have 2x times the second function prime. I have to use dy over dx. The right-hand side does not have y. It's just the independent variable. I bring 3 down, so I have 12x squared. So I differentiated the left-hand side to get this. I differentiate the right-hand side to get this. Now I am after this piece. I have to solve for it. At this point, this is a linear equation in dy over dx. I will move this to the other side. And since I cannot combine like terms, what do I have to do? Because I have to solve for this. These are not like terms. Whenever
Isolate.
Yes. How?
Subtract 2y.
No. No, I have two terms. I have two terms that contain the variable. And they're not like terms. So what do I need to do if I cannot combine them? The keyword, one of my
Divide.
can't. One of my two keywords. I am big on two keywords.
Do we factor it?
Yes, absolutely. I have to factor out the variable. So then I have e to y plus 2x. Who said that?
Yash.
Thank you. And then I have 12x squared, and of course minus 2y. So then when I solve for this, how do I solve for it?
You put the dy dx term on top.
This is one unit. No one can break this apart. I'm solving for this.
We divide by.
Right. I divide this piece by this piece, of course. Thank you. Who said that?
Yash.
Thank you. So if you say, oh, big deal, what did you accomplish? You found the derivative of the function, but it depends on the function itself. Well, I can't do anything about it. But if you give me a point, if you say x is and y is, I can give you the number here. And I can say, well, I cannot solve this equation for y, but look, if you give me a point of the equation, I can give you the rate of change of that, whatever it is, when x is and y is. So it's still a huge leap forward, although I cannot determine this explicitly because I don't have y. This is how implicit differentiation works. So this was a problem that I just made up. So we're going to choose another. Any questions on this?
Yeah,
I'm ready.
wasn't following that entire time. I was listening, but I really didn't understand how everything was going on.
Well, let's look at another example, and then you'll see how you feel after the second one, and we can come back to this one. What do you think?
Sure.
Okay, so let's look at another example. And if that doesn't help, we'll go back to the first one. And I think I'm on page 3. Am I on page 3? Yes, I'm on page 3. Okay. So I'm looking. What about? I'm looking at different problems in the old edition. If you'd like to choose, you can go to the book, to the ebook in 3.5. You can feel free to choose. In the meantime, I'll choose one. X plus y, the square root, equals 1 plus x squared y squared. And of course, we're asked to find dy over dx. Two things. The notation has to be this. I don't want to say has to be mandatory. If you use y prime and you do it correctly, you get 100%. But I highly recommend this notation. And secondly, it tells us that y is a function of x. If you have any difficulties with that, just put a mark under the function, so you don't forget that that is a function. It's not a variable. You cannot differentiate that as a variable. Okay, good. So I'll differentiate the left-hand side. No one can solve this. No one can solve this for y. Maybe if I square, no, still you have x. you cannot even isolate, not solve, not even isolate. Okay, so I differentiate the left-hand side. And remember the rule. The square root of a function prime is 1 over 2 the square root of the function times the function prime. So 1 over 2 the square root of x plus y. In parentheses, the derivative of x is 1, but the derivative of y is dy over dx. Equals.
So I have a quick question.
Please.
So I forgot about that when you were doing the homework, like how you could change the square root. If I just change the power to like x to the 1/2 and y to the 1/2, would that work also?
Oh, absolutely. But you're wasting time, because a long time ago I thought we carved this in stone to cut back on time, but I'm fine. I'm absolutely fine. I just don't want you to work too long or too hard. This is carved in stone. Now, if the index is 3, then you have no choice. But you have a choice with index 2, and this is the choice.
Okay, thank you. I just want to double check.
Yes, everything is fine. So then I differentiate 1, I get 0. This is a product. Function 1, function 2. When I differentiate a product, I have to have two quantities. I differentiate the first times the second, plus I keep the first times, I'm differentiating a function to a power on the side. Function to a power, n, f to n minus 1 times f prime. So 2 times y times dy over dx. Now, I will rearrange a little bit here, and this piece, this has to be distributed to 1, and this has to be distributed to dy over dx. Why? Because my variable is in here, I have to take it out of there somehow. This is my variable. Nothing else. I'm solving for this. So then, I will distribute